Okay. I think this is working. Now start streaming. Stop video. Why doesn't it show? Let's see. Just checking to see if the stream is working. Let me share my screen now. All right, yes, it's working. Good. Let me take out the chat. Just put it on the side here. All right. All right. All right, welcome everybody. We are finishing up the 5th week. We're getting close to halfway point to this course. We'll have one more week next week, and then after that will be the midterm exam. Let's just review real quick. We started our first week doing installation of a relational database, MySQL. We created a simple table. We inserted, deleted, updated, retrieved some simple data from there just to get our bearings and making sure that the database was working. Then we spent about a week talking about how to design the database using UML class diagrams, implementing several concepts, I guess one-to-many, many-to-many, and several other ways of structuring our data, making sure that it was normalized, breaking it up into multiple tables. We spent some time converting that conceptual graphical model into something much more concrete that we call the relational model, because we're using relational databases. We then spent some time last week on how to retrieve data that has been already stored in that database, doing simple select statements and group by and unions and that sort of thing. And this week we're spending some time on learning how to update the database, how to do inserts, updates, deletes, right? And so we'll finish that up today. And I do want to go over the previous quiz number 2, just to talk about a couple of errors that we have identified, and we're going to be grading manually and giving you some points back. But I do want to talk about in general, somewhat the expectations of these quizzes and what the intentions is and what you should expect. So we are, as you know, obviously we are running these quizzes asynchronously to give you a chance to take this whenever is convenient for you. We give you a 48-hour window. So for instance, the quiz today went out early this morning, and it'll be there till Saturday, tomorrow at midnight. And so because we have so much wide range of time, I might not be available, or the students, other TAs might not be available if you have a question. So we're trying to automate this as much as possible and minimize any need you might have from us at any one time. So to simplify, we are trying to make this really, really simple. The questions are going to assume that you are not going to need periods or commas or semicolons. Now there might be questions that are specifically evaluating whether you know that you need a comma or period or semicolon, and in that case, we will make it explicit, right, whenever you do need to use a period or some kind of punctuation, right? But in general, right, we're expecting that your answers are not needing any of these punctuations. Also, same thing with semicolon, quotes or double quotes or backticks or anything like that. Again, the types of questions that we're going to put forth, right, should not need any quotation marks, right? Also, no need for any extra spaces. Please abstain from using an extra space somewhere. or tabs or new lines or anything like that, right? It should be just straight the word that we're asking for. Also, we're not going to give you a question where we're trying to trick you and put in some syntax error to see if you catch the syntax error. And the answer is no, the answer is wrong because there's a syntax error you didn't catch. All right, so we're not going to trick you in that way. If there is a syntax error, you should just ignore it or make the best of trying to understand what it is that the question's trying to ask you. It's not intentional, and if there is, please let us know, and we'll correct it and perhaps even give you points for having found the error. Also, the fill in the blanks. In general, fill in the blanks. In general, we're expecting each blank to contain a single word, right? So if there are any compound words or complicated words, we'll put the possible answers in such a way that you could have written it with a single word, as a compound, or split it up into multiple words. Ideally, you will automatically just split up into two different words, right? So please, if it's a compound word, split it into multiple words, right? One word per blank. Okay. Obviously, there are some words that you can't split. Like if you say auto increment. So auto increment is auto underscore increment, right? So that you can't split, even though it's two words, it has an underscore underneath and should be treated as if it were one single word, right? But group by, right? I've seen some folks that are writing group space by in the same input field, right? So that one's kind of clearly should have been split into two, group and then by, right? So please break it up into those two words. Now there might be questions. What does JSON stand for? And so it's JavaScript object notation. So is JavaScript one word or two words, right? So that's some kind of edge cases where that one I would say it's a compound word. So it would be Java and then script. But again, we will try to make it so that the answers will take both JavaScript or Java, so that you'll be able to do it one way or the other. All right, so those are some of the basic. Also, lowercase. Everything's lowercase. So even if you see that the answer should be uppercase or camel case, or we're going to make it so that it's case insensitive. So even if the answer is clearly uppercase, lowercase, blah, 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 right? We're going to make it so that it'll ignore a casing. But to make it simple on everybody, just assume that everything is lowercase, okay? All right, so let's take a look at the questions. So there were a couple of mistakes on our part. Let me show you. So this one was pretty straightforward, right? We're asking you, given this UML diagram, fill in the blanks to create a statement that implements an equivalent table, right? So this was table A. A is int, varchar, date, and tiny int. Okay, so here's the first thing, right? Some of you answered date time, and that would be perfectly fine, right? So we're going to go through manually and give you points back. If you did answer date to time, we'll give you points back for that. For tiny int, if you use Boolean, we'll give you the Boolean as well. Okay, so tiny int was the preferred answer, but we'll take Boolean as well. For that, we'll need to do it manually. So it's going to take us a little time to go through these manually and fix this for you. Then in one-to-many, here you were asked to implement the following relationship between tables A and B. Now this was these questions were a set of questions that you are going to you got randomly. You either got this question, or this question, or this question. Okay, and the intent here was that you're taking this on your own, and there's no way for me to enforce whether you're cheating or not. So I'm gonna I'm gonna try to do these questions in such a way that they are randomly generated, so that some people are getting one question, other people are getting, so that it's not obvious. If some folks are not being honest, we want to encourage you to definitely work on this on your own. Now, all these questions should be all the same, except that perhaps the names of the tables might be different, the values might be different. A few things that obviously you would try to comb through this to see if it's the same question or not. Okay. Anyway, so this one says, consider tables A and B. We are trying to create this relationship between the two. Many instances of B, right, are related to one single instance of A. So here's A, which has its own primary key, and B has a foreign key that points to A. So that's definitely a one-to-many, right, between A to B. Yes? This one was the same thing, right? So if many instances of X are related to one instance of Z. So same thing, right? X has a foreign key to Z. Here's where I think we made a mistake. Okay, and this says many instances of R are related to an instance of T. So this should have been T, and this should have been R, right? So that's we made a mistake there. So we will fix it, and we'll just give anybody who got it wrong. We're just going to give you the points, because we don't know whether you got it wrong because you didn't know, or because we just it was written incorrectly. Okay, so we'll give you points on that. Then there's a many to many. We asked you to implement three tables, A, B, and C, and we wanted to implement a many to many relationship between A and B using C as the mapping table, right? So we have just A and B just having their own primary keys, and then you have C, which had a foreign key to both of them, right? One to the foreign key of A and the other the foreign key of B, right? And there were several versions of this. I believe there were no errors here. There were no mistakes here. This is, again, this was just with W and Q, and then having the mapping field table E, right? So these are the same as before. Or you might have gotten A as D. So same thing, right? We get the two tables A and S, and then the mapping table D. Okay, so I don't believe there was any syntactical error there. For the self-reference, again, I think there were 3 versions of this, and we wanted to create a self-referencing, right, where you had table B referencing itself, right, where you had B having its own primary key and then referencing itself in B, right? So same thing with X, right, where you have table X, and then table X has a primary key, which is also a foreign key that references itself, okay? And here's R, and here we made a mistake in R. Let's see, we have a create R, and notice that we left in the X. See that? That makes no sense, right? That was supposed to be R, and that references R and references R back way. So again, if you got this wrong, we're just going to give you the points again because we messed up in the syntax there. So if we lost points for something that we think might be acceptable, should we contact you? Yes, if you have any questions on whether we should, I mean, these are the things I'm pointing out, right? That we know there might be a couple of mistakes on the quiz, and then we're going to go and fix it ourselves without you having to tell us anything. But if you know that you have something else that you want to point out to us, please reach out and send a private post on Piazza, and we'll look into it. If we see that this affects all the students, we'll go in and retroactively fix it for everybody else. Okay. All right, excellent. Right, so that's the quiz number 2. Any other questions? All right, let's move on. All right, excellent. So let's see. We for this week we already covered some of the material earlier this week, right? We talked about inserting into the database, and we talked about that there were several versions of the insert statement. One that allow you to insert by omitting the names of the columns and only providing the values. And we saw that that command was able to map the values by their order, right? And so the first value mapped to the first field as described in the create statement, and the second field with the second value with the second field, the third value with the third field, and so on and so forth, right? Following the order of declaration in the create statement. We talked about also an alternative syntax where you can specify the actual columns, right? And so the order is given by the columns that you list there, and so you can then provide the values with in the same order that the columns that were listed there. And we also saw that another syntax was to be able to copy values from another set of tables, right, and copy those into a table. Insert into select syntax, right? We also spent some time talking about updates and deletes, being able to identify those records that we want to update, and then setting those new values to those existing fields, or removing records from existing records from a table using the delete statement, right? We also spent some time early this week talking about group by and some of the limitations of using group by, because of when the records are identified and then grouped by, right? That happens right after the where clause, but before the select statement, and because of that, there's some limitations on what can you put on the select clause, right? That you can only put either fields that you grouped by, or fields that you aggregated, right? Aggregation fields. You can do that, right? But you can't put fields that you did not group by, right? Or you're not aggregating. That would be a syntactical error. So we talked about that. So let's move on. Let's talk about a couple of other things. Let's talk about modeling classes, class inheritance using SQL. Okay, so as we had mentioned earlier, right there, when we talk about the structure of the data that we're storing, right, we oftentimes think about the structure at a very high level, using conceptual diagrams such as UML class diagrams, right? And such as these, for instance, right? You create these classes, and then you use all sorts of association lines, and use cardinality to say that so many of one instance are related to so many others of some other instance, right? And we saw that we came up with an algorithm that allowed us to bridge these two representations, the representation in the class diagram. We then saw, well, how can we convert this into an actual table or set of tables, and go from the conceptual model going down to the relational model, right, within a relational database. And we saw that these associations with lines and ones and asterisks and cardinality can be converted into tables that then had primary keys and foreign keys and whatnot, right? So we did all that conversion. We saw that there's some limitations or some challenges on how to go from one representation to another representation. But that divide between these two worlds, right, the conceptual object-oriented world, right, there's certain things that just don't have any equivalence in the relational world, right? It's because the relational world existed much earlier than the object-oriented world, right? The programming languages have evolved alongside one trajectory, and databases have also evolved in a different trajectory. And so many of the things that were invented in software engineering, all the best practices and how is it that we can become more productive and create modularity and reusability and understandability and division of concern, and all this plethora of techniques and architectures and design patterns that evolved in software engineering, they just didn't translate or had no equivalence in relational databases. But nevertheless, right, we still want to design using the best practices and using object-oriented technology, but then they need to be translated into something concrete that we're going to store in for permanent storage in a relational database, right? So there's a divide between these two worlds, right? And sometimes they refer it as to the relational impedance, right? There's like a gap, there's an impedance going between them, right? So we're going to look at those first challenges. Up to this point, we were able to go really easy, right? Being able to do many-to-many, one-to-many, and easily convert them by reifying, right? We can convert a many-to-many into a reify table and doing, adding a new table that can point to the other two tables, right? And one-to-many with primary key, foreign key. That was easy to do that gap of how to interpret or represent them in those two worlds. But here's one of the first one that is a little more challenging. And it's the inheritance, right? How, if we see this in a UML diagram, it says, well, how do we convert this into a set of tables? What do we do with this, right? And so now we have to consider, what does this mean in object-oriented terms? Well, I mean, what does this mean when they give you a diagram like this, right? Where you have, a superclass, the question being a base class or superclass or parent class, right? There are many different ways, names that we give this type of class, right? And then we have these subclasses or child classes or subclasses, right? Or derived classes. And the concept behind this is that presumably the idea was that, hey, here are three classes, right? That they all have features such as they all have like a title, they all have a name, they all, these are all questions in a quiz, for instance, right? So all questions in a quiz will have, how many points each question is, and maybe a description, the actual question in that question, right? Maybe some instructions on how to answer that question. So all those are attributes of all questions in a quiz, right? And so object orientation suggests that, hey, instead of declaring points, right, in each one of them, why don't you instead declare a superclass, right, that can have all the attributes that are shared, that in common with all the subclasses, right? So instead of declaring these, 2, 3, or 4 attributes again repeatedly for all these classes, well, let's group all of them, all those attributes that are shared amongst all the subclasses, and put them in a superclass. And then you can say, we can invent the idea that these inherit, right? That a subclass is just a special case of this superclass, right? An essay is just one special type of question, right? The fill in the blank question is just one specific type of a question. Same thing with the true false question is just a specialization of a question, right? So a question is a generalization of each one of these three special cases of questions. Yes. So we say that these sub or classes or derived classes, they only really declare things that are specific to themselves, such as true and false. Question might declare that the right answer is that that it's true or false, right? That's the right answer, and that information only makes sense under the true false. It's a special piece of information that is only relevant to the true false, right? But title and points and description and instruction, that's really not specific to true false. It's actually something general to all types of questions. That's why we declare it up here, but not down here. Same thing with fill in the blanks, right? It has a special attribute called variables, which is only makes sense for the fill in the blanks, right? All the variables that we're going to fill in the blanks for, right? But then all the other attributes are just in common with all the other siblings. Yes, so don't declare them here, declare them up here. And then we say that these all inherit, right? They all inherit down to the special case, right? These all inherit these base attributes. Yes. So that when you create an instance of these classes, when you instantiate, you say new, true, false, or whatever, you should expect from within the true false class or the instance, To have access to variables is true. Also have access to variables title, point, description, and instruction, as the single instance of true false, right? So when you create the instance, you have the access as if this were one thing, right? That these are really, a merging of the questions and the true false. You're merging the data into one single instance of the true false instance, right? Which includes your special variables, right? Plus all the generic variables that you are inheriting. That makes sense? So that's from the object-oriented standpoint. So how do we actually, now, all this is good and it works in a language and in an environment where data is being created and destroyed, all the time, right? In a CPU, in memory, in volatile memory, RAM, right? As the program executes and is running and I'm rendering the user interface, blah, blah, blah. All these objects are being created and destroyed all the time because they're very volatile. So how do we convert this world of a very dynamic world that is changing, every minute, right, every second? How do we convert that data and transform it into something that needs to be stored permanently, right, for long-term storage, right? That we need to convert it into tables, and to remember that these are the questions that I'm going to render in the user interface, or these were the answers for so and so when they were taking this quiz. So there are several strategies that we're going to consider, right? In particular, because relational databases don't have this concept of inheritance. It's a foreign concept in a relational database, right? But nevertheless, we structured it, we designed it in this conceptual model, and so we need to be able to map this into a relational model, right? Something that is concrete, that we're going to store this data in the database, right? So what do we do? Right, so there is no equivalent. First of all, there is no equivalent. Instead, the best thing we could do is try to approximate, right, what happens in volatile memory, right, and try to see what congruency do we have here in a long-term storage, right? So in particular, we're going to consider three options, right, on how is that these classes are going to be converted into tables. One is going to be the joined strategy, right, or sometimes referred to as the normalized strategy. The other one is the single table strategy, which is also referred to as the denormalized strategy. Then you have the per class strategy, which is kind of like both of best worlds between these two. These two both of them have pros and cons, and the hybrid version is going to try and marry together what's best about both approaches into one single approach. Okay, so let's just take a look at the first one. It's the joined strategy. Okay, that also AKA, make this smaller, AKA the normalized. Normalized. Oh, it's too big. Again, normalized. Okay. All right. So the reason it's called normalized, right? The reason it's called normalized is that it applies normalization, right? That we've come to be familiar with when we looked at normalization, right? Well, the strategy was that if you had a lot of data, right, we don't want to put it all in a single table. Instead, we create multiple tables and only store a piece of information only once, right, as records of a particular table, right? So since we have 4 classes here, the general approach would be that to have 4 tables, right, where one of them would store the question, right, that only the information that was specific about the question, right? So for instance, the title, the points, the description, and the instructions, and then they are, right? There they are. Those are the 4 attributes that are specific to that table. Plus, obviously, we'll have maybe a primary key, right, that we declare, and that's it, right? So basically, we store that information in each one of the records in this table. Yes? What about the other ones, right? So we still have your essay, fill in the blanks. Let's take just these 2 down here, fill in the blanks and true false. So for the true false, here it is. The true false, has an inheritance relationship with question. But notice that the only thing that this table is storing, right, is is only that field, that specific field, right, that is special to this one table, which is the is true attribute, which is Boolean. So we're going to go with tiny int. Okay. And probably a primary key, and as declared here for the ID. Make sense? All right. Now, but how do we capture the fact that here we have true, false, presumably is inheriting from this question? How do we capture that idea? Well, the way we're going to capture it is that the way you're going to use it in memory, right, is that when you inherit, right, and you create an instance of true, false, basically is going to have fields that belong to you, plus any fields that belong to your parent record, right, parent instance, right. So you're going to be treated as one thing with some attributes from your base class and one attribute with on your own, right. So the way we're going to capture that is by joining records, right? Joining records between the parent and the child. So some information will live in a record in this table, and some of the information will live in a record in this other table. So at some point, we're going to have to join these two to recreate the original instance that has information from both. Okay. So to be able to join, they need to have a relational. We need to capture that relationship. The way we're going to capture it is that the top base class, right, which is which is implemented in this table, is going to have a primary key, and any derived classes is going to have a reference that references the primary key of the other parent class, right? And notice that for the foreign key, we're using the same primary key. So ID is not only a primary key, but it's also a foreign key. Basically, this is a one-to-one relationship, right? Right. So for one record that you have in the base class, there is a one record implemented in the derived table. Okay. So there's a one-to-one relationship, and when we join the two, right, it becomes one single thing. That makes sense? We also probably would put here a delete cascade deletes, right? So that if you remove the record from the parent table, well, if you don't exist, well, I shouldn't exist either, right? If that instance, the parent instance, goes away, well, I should go away too. It would make no sense, right, to be able to have a record in one of the table, but no equivalent record in the other table. Okay, so typically this would also have a cascade delete, right? Same thing with the other derived table, right? The fill in the blank, same thing, right? It declares a field that is specific to that table, right, for that class. Have a primary key, right? Plus the foreign key is what establishes the one-to-one relationship between an instance in this record and an instance in the parent record. Make sense? All right, so yeah, that's the implementation, and obviously when you're going to read this data and reinstantiate it and bring it into memory for representing it maybe in the user interface, right, you would have to join these two tables, right, to recreate the instance of a fill in the blanks variable in memory, right? Now there's in the database, it would look something like this, right? So where you would have in the one table, in the base table, right, you would have records that would hold values for the attributes that are common to all questions, right? Like description, instructions, points, and title. That all questions have this, right? So here's question 2, 3, 1. Here are the specific questions, specific question number 1, question number 2, for IDs 3 and 2 here, right? Which have data that is specific to them, like is true or variables and whatnot, right? But they also have a foreign key, which is also its primary key, that is relating itself with the other records declared in the other table, right? These 2 and 3, right, are being referenced by this 2 and 3. Right, so and there's a one-to-one relationship between the two, right? So that we instantiate, we would join the two to recreate the object in memory. Now, there's a couple of pros and cons. In general, this is very easy to understand, right? It's very intuitive. It's normalized, right? Meaning there's no redundancy, right? The information is captured in separate tables. So no redundancy. There's no inconsistency. And now the problem is that because it's it's split up into multiple tables, right? And because we know the way it's going to be used, we're always going to have to join all these tables, right? Imagine you had a top level class, super class A, and you have a subclass B, right? That means that to recreate the instance, you're going to have to join A and B, right? And that's not too bad. But imagine, it's very common in object-oriented design that you create these long chains of inheritance, right? Where you have superclass A and then subclass B and then subclass C and then subclass D and so on and so forth, right? And it's not too bad if you are working just with A and B, but if you're trying to instantiate D all the way down here, right? That means that you're going to have to join A with B with C with D, right? And so that joining of so many tables, that is no problem in object orientation, right? Because you're inheriting all that, and compilers, know how to do that very quickly and very fast. In a relational database, that's actually very, very expensive, right? Remember that, when you iterate over one table because you're looking for records in a table, right? That's order n, right? You're iterating over that, and if the table is twice as big, then you'll take twice as long, right? But when you add a join, that means that now you have to do a cross product, and you need an outer loop that loops over one of the tables, and then another inner loop that loops inside the other. So it becomes from n1, order n, it becomes order n squared. And if you have 3 tables, then that's order n cubed. If you have 4 tables, it's order n to the 4, right? So this becomes exponentially hard, right? When you add additional inheritance, and it becomes very expensive to implement. So it becomes very, very slow as the inheritance chain gets longer and longer. So this is oftentimes not used unless the inheritance is very shallow. Then maybe makes sense. But more in general, typically we don't use this strategy. Instead, we use this other strategy called the single table implementation, aka the denormalized implementation, right? So let me single table. Let me make this smaller, and let me just put here aka denormalized. Okay, and what this strategy tries to do, it tries to address the performance hit, right, that the normalized version has. Okay, so in this strategy, what it does is that it takes this long chain of inheritance, right, and what it does is it flattens it, right, and instead of having attributes in separate tables and in separate classes, as if you took all those 4, 5, 6 different classes that are in the inheritance and just squash them into a single class that includes all the fields, all the attributes from all the classes that were in that inheritance chain, right? So what you end up with is one big class that has all the attributes from all the inheritance chain, right? Which gets translated into a single table, right? A single table that has all the fields from the base class plus all the fields from all the intermediate classes, all squished into one single table, right? So notice these are the fields that we are grabbing from the base class, and then each one of these are from the individual classes as well, right? So now before we did the squishing, right? You could tell that each instance was implemented from whatever class because each one has its own class. But now that it has been squished, you kind of lose that information, right, of saying what am I? Am I this instance or am I that other instance, right? So to alleviate that, we add another field here called the D type. The name doesn't actually matter, but the intent is that we want to capture here information enough that we can use to determine later when we instantiate this, what was your original instance, right? What was your original type? Okay, so this is sometimes referred to as the discriminating field, right? The discriminator, right? Not in any bad sense, which is going to allow us to determine whether you were this type or you were some other type. Okay, So here, for instance, you would have one big table that where you have values for the comments part, right? That all questions have, such as description, instructions, points, and title. All questions have that information. But then you have columns that are specific to different types, right? If you are a fill in the blank, then you have values for variables. If you are a true false, then you have values for the is true. Whereas all the other ones are null. See that? All nulls, because I am not a, if I'm a true false, I am not a fill in the blanks. If I'm a fill in the blanks, I'm not a true false. So I wouldn't have values for those fields, right? So I would have just null, right? And the D type has information there, maybe from a numeric data type, or the names of the original classes would be used to then determine what instance were you, so that I can read you back into memory and instantiate the correct class, okay? Now this one is the pro here is that because we've squished everything, we put it into a single table, right? The performance is much better. We don't need to join all these, all these tables to recreate the original instance, right? So this is much better performance than the joined or normalized version, right? The con here is that you can have redundancy, right? Where you can have many a lot of information about the D type just repeating itself, and so that can breed inconsistency. So oftentimes all these strategies, we don't use them by hand. Is not going to be a human being who actually creates these tables or inserts or updates or deletes. It's actually going to be used as a strategy where we automate all this, right? And we have algorithms that have been vetted, they have been QA'd, they have been, that we know we work, right? That know how to make sure that we're not going to have any inconsistency, and that we can manage the redundancy, so that we can have the best performance because of redundancy, but we're going to, without the bad parts of inconsistency, right? So we'll talk more about that. It's a technique called object relational mapping, right? That we'll talk about it next week, that allows you to map these two worlds, right? Of mapping the object-oriented world, right? Mapping it to the relational world, right? ORMs, object relational mapping. So that's for next week. There's an alternative version of that kind of borrows from both of these ideas, right? That we do want the normalization part, right, where we're trying to avoid redundancy, but we also want the performance of the single table denormalized strategy, right? So table per class strategy kind of borrows from both, right? So we do have, if we have a long chain of classes, we do have one table per class, like we do in the single, in the joined normalized version. And each one declares the fields, right? Just like we did before. But when you go down to the other subclasses, what we do is that not only do we have our own fields, right, that belong to us, but we are literally going to copy over, right, all the information from our parent down to us, right? Very much in the spirit of inheritance, right? All the fields that were declared in the parent, I'm also going to declare it down in the child, right? Again, following the theme that whatever my parent has, I also as well have, right? And the data would be duplicated, right, in each one, depending if I'm retrieving my parent or I'm retrieving the child. And all the data is right here. There's no need to join, right? And I don't need to join with my parent to fetch the data from my parent, right? I have all the data here, right? So I get both the best worlds. Since I don't have to join, I get the performance of denormalized, but then I also am storing the information at each level, once at that level, so that I'm getting the benefits of normalization. Okay, so both have you get both the best worlds. Okay.
Is the con for this that you take up more space?
Yes, the con is that exactly. You're exchanging time for space. Yep. which the answer might be, so, well, space is cheap, right? And oftentimes we value much more the time.
All right, got it. Thanks.
All right, let's talk about pagination. All right, so databases are well known for storing long-term storage, right? Creating long-term storage solutions that are storing huge amounts of data, right? Where it might be thousands, tens of thousands, millions of records, right? And now oftentimes usually we don't consume all that data all at once. It's usually we consume only small snippets of that information at a time, right? So there are many strategies that we follow to allow us to deal with subsets of data, right? So for instance, we might reorganize our data based on some kind of category or some genre. So for instance, if you're going to Netflix, right, they'll even, they might have thousands and thousands of movies. How can you possibly find anything, right? So they'll organize it by category, by genre, by your preferences, your history, and even then, still, it'll be a lot of data to go through. So oftentimes they'll additionally allow some mechanisms that allow you to search, right, and or paginate, which we're looking at right now, right, where you are consuming chunks of data in some kind of range or pages, right, where you'll see maybe 10 movies at a time, and then you can click on the next, right, and then you see 10 more movies, and then next, and you can see 10 more movies, right. So databases need to support that behavior, that mechanism that allows you to kind of skip over, a sub range of your result set. Right? You might ask for a particular category, genre, date, and a specific query, right? And it comes back with 100, 200 records. That's still too much, right? And so we need to be able to say, well, okay, well, skip 10 and then show me the next 20, right? And so databases allow you to do that with commands such as top, for instance, in SQL, and in SQL allows you to skip over, right, and see the first 10, the first 20 of the results of some query, right? So for instance, you can say select yada 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 where, and that comes back with maybe 1,000 records. And top allows you to just split and just filter out and only return the first couple of records, maybe the first 2, the first 10, the first 100 records. You can say it by number, or you can say it by percentage, right? Give me half of what you got, right? So here's an example of using top, right, where you retrieve all the persons that might come back with based on some criteria, right? And then you just want to see the first couple, right? And here, because we have 4 records on both cases, right? Top 2 and top 50% returns the same 2 results here, right? Now, so that's SQL Server. Now, MySQL, right? Each vendor kind of has its own way of doing it. MySQL uses the keyword limit. So limit works the same way, right? It allows you to specify that out of the 100 or 200 or 1,000 records, I want to see the first 5, right? Where you can say limit 5, right? And then we'll only show those 5. Okay, let's see. I think something on the chat. How is that different? It isn't. It's exactly like limit. Is this like the head bash command? Yep. Or tail, right? Also, right? You can say the tail or the head, and you can just see only the first couple of lines or the last few lines. So same thing. So yeah. So in MySQL, the command is limit, right? In SQL Server is top, right? So it has different names, but they do the same thing. Now in Oracle, it's slightly different. So we're just looking at different strategies different vendors use. In Oracle, it's slightly different. They use Oracle defines a field whenever you do a query. Oracle, after the where clause, right, after it identifies which are the records that meet your criteria, right, and it says, okay, well, these are the records that meet your criteria, and it calculates, it adds a field to that result set called row num, and it does it after it calculates the where, right? After it calculates the where, it goes on, it says, okay, well, this is the first one, the second one, the third, yada yada yada, right? As part of that where clause, okay? And so you could use things such as row num less than in a particular number. And the way it works is that it identifies the first item, right? At first, you don't have a row num, so they're all less than any number, right? So the first one will be 1, right? So it meets the criteria, so that goes in. The second will be 2, right? 3, 4, 5. When it gets to 5, that's still less than 5 or equal to 5, and that still goes in. So 6, it doesn't meet the criteria, so those are all filtered out. Okay. Now the problem that with runum is that it has a couple of limitations, which we'll show you here. Right. For instance, row num greater than 5, where you might want to say, I want to skip over, right, the first 10 or first 20. You can't. This actually doesn't work, right? Because none of the lines, none of the result set would be the first line, right? The first results, first row would not meet this criteria, right? It's not greater than 1 because I haven't yet assigned a row number on that record, right? So because I haven't been able to assign to the first in the result set, I can never increment to 2 or 3 or 4 or anything like that. So I cannot advance. So this would return an empty result set. Row num greater than 1, right? The first one can't be greater than 1, right? So I'll never be able to advance the count for row num. So that's a big limitation in row num that we could get around. All right. So let's see different strategies of getting around some of this limitation, right? Between works, you can say between. Greater than, but less than, because the less than, they're all less than. So it allows you to calculate 1, 2, 3, and 4 until you get to 5, right? But then you can definitely make a range. You can say between 10 and 20. Well, they're all less than 20, right? So I can calculate 1, 2, 3, 4, 5 until I get to 10, right? And I calculate all the way to 20, and then I can filter out and only keep between 10 and 20. So definitely this works, okay? But even so, even though this works, it actually breaks if you start combining it with other commands such as OrderBy, right? Which doesn't break for SQL Server or MySQL, but it does break with row num, right? So let me show you some of the limitations. So for instance, here we have a simple select, right? And we come back with Clara, Deborah, blah, 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 and this where clause. I want to see all the employees whose last name is Smith, and I have 10 employees who are Smith. And having identified these 10 folks, right, the row num is calculated for all of them, 1 through 10. Okay, no problem there, right? We're not trying to skip anything, but it returns these 10, which is fine. Now between also works, right? You go between 1 and 5. And but notice this 1 and 5 is these first 5 right here, right? These first 5, which is what you expect, Clara through Keith, right? Which is fine, right? This is exactly what we want, except when you start combining it with other commands such as OrderBy, right? Now OrderBy, the problem with OrderBy is that the row num, right, is calculated all the way up to the where, right? Once it gets to the where, it calculates all the row nums, right? And then when it gets to order by, it might do the correct thing. It order buys correctly like that, yes? But notice that the row num is what the original row nums were all the way up to where here. See that? That's a problem because now you can't use row num in the logics that you would want of between or greater than or less than or anything like that, because the row num is not recalculated, right? Of this being again 1, 2, 3, 4, 5, right? So any logic that you add here about order by location, if it comes back with 100 elements and you want the first 5, those first 5 are not going to be necessarily in the order of the order by location. It's going to be the first 5 of where the where happened before you did the order, before you did the order by location, right? Because the order or the row nums are all screwed up now, right? What you would have expected here is 2, 3, 4, 5, but instead that's not what you get, right? Let me format this as strike through, right? So this is not what you get. Instead, you get this weird, reordering of because you did the order by, right? And so you're ordered here by location, right? Not by the row num. So any logic that you put in there of row num between 1 and 5, right, is not going to be based on the location, and they're all screwed up now. Okay. So anyway, there is a way around this. There is a way around it. It's kind of a hack, right? But let me just show you. So it basically entails forcing the recalculation of row num, right, before you do the between, right? So instead of having the between in the logic in here, is to instead have an intermediate select statement that brings in all the data from an inner select statement, right, and then forces the row num to recalculate, right? So the inner statement first does the ordering, and we want to maintain that order, right? We want to maintain that order. So the outer select statement just copies over the results of the inner one into an outer select statement where the row num is recalculated, and we are copying all the fields from the inner inline query. Okay, so these row nums are now in the correct order, 1 through whatever, right? Not all screwed up like we saw earlier. So now, because now they're in the correct order, now it makes sense that I can do the between 1 and 5. Okay, and so now it works, right? Now, unfortunately, I believe Oracle has fixed this in one of the latest versions, but nothing as simple as what you have in SQL, in MySQL, or in SQL Server. Rather, you can just use limit. Limit is just simple. You say, I want to start at X, and then I want so many Y, right? So this syntax is so much simpler, no hacks, right? And it works very, very well. Okay. All right, that makes sense.
Do we have to know the Oracle commands, or
No, you
just...
don't.
Okay.
No, I just want to point it out, right? If you ever run into that, it might even be an interview question.
Got you. Thank you.
Okay. Top limit. Blah, 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 blah. All right. Let's do store procedures. All right. Awesome. Excellent. Wait a minute. Hold on a second. I'll be right back. Just a second. So let's talk about store procedures. Right. So up to this point, we've been using SQL to be able to manipulate and interact with the database, right? Being able to insert new data, retrieve data, update, and whatnot. Yes, and the way we've been doing it is, we've been using somewhat of a kind of like a declarative language, right? Where we tell the database in a pseudo kind of English language that that we want to that we want, explaining kind of the information that we want from the database, right? And now this has worked fairly well, but it has, quite a bit of limitations, right? First of all, it's a language that was designed for non-programmers, right? That try to kind of lower the bar of entry for folks that were in the software engineering field, and we try to create somewhat kind of like a pseudo English language that non-technical folks could use it, right? That was the original intent, right? How can we make this as simple as possible for folks that are not programmers to be able to use, right? But us programmers definitely we're just fine with programming, right? So there's plenty more that we can do with the database when we unlock programming the database. So we're going to spend today and in the next week learning about how to program the database, right? And we're going to be using store procedures, right? It's store procedures is kind of like an umbrella term for multiple techniques that is going to allow us to programmatically interact with the database, right? It's going to allow us to apply many of the principles that we have learned in software engineering, apply them to databases, right? So, for instance, if in programming, right, if you find an algorithm that is very useful, and you basically what you do typically is you wrap that algorithm inside of a reusable function that can be parameterized, right? And then you can forget about the details of the function, and then just describe the function, how it behaves, right? And usually we call this um, uh, abstraction, right? We abstract the algorithm, put a layer of abstraction on top of it, and then we can think about building things even more sophisticated, right? We can then combine multiple functions into ever more sophisticated, more complex um, uh, behaviors, right? That are much more useful and much more productive. And so we want to be able to apply those same principles here in databases, right? So for instance, if we, instead of algorithms, um, we're going to be using scripts, right, that manipulate the database, do a whole bunch of selects, inserts, and updates and deletes, and we're going to be able to wrap them inside a function that we can then parameterize, right? We can create a function that calculates the salary of a particular department, right? If you give it the name of that department, right? And then that and maybe that's a useful select statement. So instead of having to type the select statement all the time, we can wrap that inside of a function, right? That I can pass it as an argument, the name of the department, and then it can go and do all the SQL statements, blah blah blah, and come back with an actual value. Now that value, I could then use that value as part of a bigger function or a bigger query, where I can use it in the where clause or as a select statement or whatnot, right, to generate and create even more complex and sophisticated queries and whatnot, right? And so we can create all these little Legos, right, that we can then build on top and make things even more and more complex. Yes. And functions and store procedures are going to have all the features that we are familiar in programming languages, right? We're going to have for loops and variables and if statements, branches, switch cases, and everything you could possibly think that you can do with any programming language. You're going to be able to do it in also here as well. Obviously, with the specialization here is that you are interacting with data, right? Where you're interacting with large amounts of data, right? That is permanently stored, right? And you have all the all the um, all the commands available to you that would normally be used for interacting with the database. So you have all the select statements, inserts, updates, deletes, and whatnot. Okay. So like any technology, there's some pros and cons on whatever infrastructure you are using. Obviously, the pros is what I mentioned earlier, right? The abstraction, being able to, if you find some very useful set of queries that you want to encapsulate, you can encapsulate in a function or store procedure so you can reuse that and make it modular and reusable. Security, right? These commands are typically executed right from within the command line as interacting directly with the database, as opposed to running outside of, remotely outside of the database, right? This is, if you have access to the database, then you can execute these things. If you don't, then you cannot execute them, right? Network performance, definitely this is the fastest performing executable code that you can write that is interacting with the database, right? As opposed to if you write Java or C# or Python outside of the database, they would have to go through some kind of network connection and to talk to the database, as opposed to store procedures that are executing right inside of the CPU, with the same CPU where the database is running, right? So you can't be closer to the data than within a store procedure, right? Now, some of the same, even though you're running on the same machine, that's a pro. That can also be a con, right? Since usually that database, right, is being used by many folks, right? By hundreds, thousands of people are sending commands to the database, and so the database needs to be able to respond to hundreds or thousands of requests that are coming in. So if you're running stored procedures and functions inside the same machine, well, that's one additional burden, right, that you're putting on that machine, right? So you have to be careful, right, to balance out, whether you want to be responsive to clients, right, and what you might be running on that same machine. Also, from a software engineering perspective, it's yet another technology to learn, yet another language to learn, right? Another piece of source code that needs to be maintained, that needs to be go through QA, so that's additional software engineering work, obviously, and also the languages differ slightly between vendors, right? Whether using Oracle or SQL Server or MySQL, right? Largely they are the same, but there are features that the different vendors are going to lure you in and say, oh, instead of writing these 10 lines of code to do something, you can just use this brand new spanking new function, right? That is only available in Oracle. And that will make you more productive. It's faster, it's better, right? And so they try to lure you in as so you become a repeat customer to them, right? And the more you use their specific features, the more you are tied to that particular vendor, right? If you want to move over to some other vendor, move over from Oracle to MySQL or SQL Server, right? And you've written all this special code that is specific to Oracle, it'll make it just that much harder to leave Oracle for SQL Server. So that you have to weigh in how much do you want to be tied to a specific vendor. All right, so there are basically three types of things that can be executed. And let me insert, right? Let me actually move this over and over here. Yeah, that's a better order. There are three types of things that can be executed. All right. So first of all, there's functions, just plain old functions. Right. And like the name suggests, they are the simplest of the three. Okay, and and they're distinguished on certain things that they can do. They can all do certain things that only certain one of them can do, but not the other. Right. So let's take a look at some of the differences between all of them. Okay. So first of all, uh, functions functions are meant to be very much like the name suggests, right? Things that you can just call, invoke, pass some parameters, right? And it comes back with some value after having run some kind of query or some kind of algorithm, right? So they always return data, right? You pass some parameters, right? And they return some data based on the algorithm that they run, right? And they're usually meant to be executed within a query, right? Whether it's a select statement in the where clause, right? And the value that the function returns is meant to be, compared or be the results of some calculation, right? They're not meant to change any data, right? So they can do a query, they can do a select statement, but you can't do inserts, updates, deletes inside of a function, right? They're exclusively used for doing some calculation based on some data, based on parameters that you pass in, and then they come back with the results that you can use either in the select or the where clause. And that's it. Okay. So a step up from that, you have procedures. So procedures can change data, right? They can do inserts, they can do updates, they can do deletes, right? You can pass arguments to it, just like a function. You can pass arguments for it. They if you want, they can return data or not. That depends to you if you need data to be returned or not. But they're not meant to be executed they're not meant to be used as part of a statement, right? It's not like you do a select statement or where clause and the value is used to compare it against anything, right? It's meant to be like a one-off. I'm going to run this procedure. It'll do something really, really complex, add some data, delete some data, update some data, insert, blah, 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 right? And then come back saying, yeah, I'm done, right? I did all this, but not because I'm using it as inside of a select statement or a where clause. It's something that I run at the command line, right, and execute, and it's done, right? Yeah, so store procedures. And then a step up from that, you have triggers. So triggers, like store procedures, they can change data. So they can do inserts, they can do updates, deletes, and whatnot, right? Well, everybody can do a select, right? They can all read data from the database, right? But only store procedures and triggers can change data. They can update, delete, insert, right? They're not meant for calculating anything, right? They're not meant to, retrieve data, come back with a value, and then spit out some resulting data that you can then use later for something. No, what they're meant to do is they're meant to be data driven, right, or event driven, right? So that you can say, hey, if somebody is inserting a record into this table, well, I want this to happen, right? Or if somebody's updating or somebody's deleting, something's happening to a table, I want you to listen, right? I want you to listen if anything's happening to this table, and I want you to execute, if so and so event occurs, and I want you to do something, right? Maybe you want to keep track on who's changing this data, right? And so you could look at the data that's coming in, the insert or the update or the delete, and maybe you want to keep track of that, right? You want to count, how many orders were ordered, or how many were deleted, right? Or how many how many users are leaving my social network, right? And you want to keep track of record of how many deletes there were, how many inserts, and you can also intercept all these commands and decide whether you agree or not, right? Maybe you see that they're inserting a piece of information, and maybe you want to run some really complex logic and determine whether that insert should happen or that delete should happen or if that update should happen. And if your calculation, you come back to say, well, no, I don't think that should happen, you can abort that insert, you can abort the update, you can abort the delete, or let it through, right? And maybe make a record and do some inserts and some updates of your own, okay? So yeah, so triggers are very, very powerful and allow you to do really, really complex behavior. All right, so let's start with something simple. Let's start with just plain old functions. So functions, you can create a function just by saying, create function, okay? And then the function name, and you can pass some optional parameters. And below that parameters, you can have the body of the function of what is that you want the function to do, all right? So let me just show you an example, right? So in MySQL, it's very easy to create a function. You can go to your database, and below there's tables, there's views, there's stored procedures, and there's functions. See that? You can right click on functions and you create a function. So let's go there and let's see, DB design, and let's use this one. Let's use this one. Okay, let me close this. Close that, close this, and let's close that. Okay. All right, so in here, you can create a function by saying right click and say create function, right? And opens up an editor for you, right? Where you can type in the name of the function, right? By default, the function returns an integer, right? Like this is like the return type. There's the begin and the end of your function. And also notice that by default, it just returns a 1, right? So something really, really simple. So let's make something also really simple that just to illustrate what you can do. For instance, you can just do some add 2 and 2, for instance, add 2 plus 2. And your return will be, 2 plus 2. Okay. Once you have this, you can say apply, and it will convert it into commands that the actual commands that you would type at the command line if you were talking to the database directly, right? So that's basically what SQL does. That's what SQL Workbench does, right? It converts, it gives you some user interface and it simplifies things, but then it converts them into, line by line commands that are sent out to the server. So for instance, it says use the particular database, right? It removes this function if it already exists, right? In case you are redefining this function. Then notice what it does here. It's adding this delimiter. What is that, right? So delimiter refers to this right here. See that semicolon, right? That semicolon, it's interpreted by the server. It's interpreted as being the end of a command that should be executed right away. Okay, that's what this delimiter is telling me, is that you're telling me to use that particular database. Boom, I'm now using that database. Then what are you telling me? Notice another command, a semicolon there. See that? That's a delimiter. And so you're telling me that, boom, you want me to drop this function so it executes right away. Okay. Now, inside of these functions in here, we're going to have lots of statements, right? Select statements. Okay, and when we look at procedures, we'll have also inserts and updates, and they're all going to have a semicolon at the end, right? But we don't want the database to interpret that semicolon as if we want those inserts and updates and deletes to execute right now, right? Instead, we want to put them inside of a function or stored procedure so that they can execute later. Okay, so to some kind of tell the database to stop interpreting my semicolons, as execute this right now. Okay, we are going to use the command delimiter, and tell it that from now on, right, don't interpret a semicolon as the end of a line and execute this right now. Right, stop doing that. Instead, I'm going to use some bogus keystrokes here, right? That I don't intend to use other than telling you not to interpret the semicolon as the execute this right now. So I'm going to use $$. Some people use // some people use @@. So it's some kind of sequence that is easy to remember, but right, is meant for telling the server to stop using the semicolon, because I'm going to use the semicolon here, right, as telling you to execute this later, not right now. Okay, so changes the delimiter. Now notice I'm saying use DB schema just like I did earlier, but notice that before it was semicolon to say do this right now. Now the do this right now command is the $$. I'm telling them do the schema, change the schema to this right now. right? That's what this $sign means. The same meaning that it used to be attached to semicolon, right? Anyway, so use the schema. Now I'm going to create the function, blah, blah, blah. I might have here select statement, semicolon. Now the semicolon does not mean execute right now, right? To return, here's the end of my function, right? And so this dollar sign means I'm done with the function. Define the function right now, right? The function that I just gave you, boom, right? Make it so. Make the function available so I can run it, okay? Once I'm done, I turn back and put the semicolon back as the default delimiter, okay? So that when I run the function, all the semicolons that are in there should be interpreted as in do this, execute it. Make sense? All right, so notice that my editor only gave me this piece, my editor, right? And notice that it added before and after all this other garbage, right? All that is so that it's interpreted by the server, as the creation of this new function, right? All right, so let's apply. It applies it. There we go. So it's
So
applied. Yeah.
does the end term go back to the create function statement or the begin statement? Does it just automatically go to the nearest one?
The end, yeah, the outer one. I'm sorry, no. If you can have nested begins, right? So it's the one that matches.
Okay, cool. So it'll automatically match them.
Yes, it automatically matches. Yep. Looks like there were some questions on the chat that I was missing. Let me see. How's it? Is this like the? Yep. Proprietary. Yes, proprietary. I can barely pronounce it. Proprietary. Thank you. Yeah. So okay. So we define that. How do we use it now? Right. We'll start off. Let's start. Oh, I have other things here. Let me close that. SQL 6. I guess we can close that. I don't need it. Close that. Close that. Okay. So how do we use it? So the way we could use it, as you remember, right? Functions are meant to be used from within select statements or where clauses, right? So for instance, I can say select, right, and then use my function. You can say add 2 and 2, right? And if I run that, right, it comes back with, there it is. See that the result set or the result grid, right? By default, it takes the name of the function as the name of the column, and then what it came out to be 4, right? I can rename that. I can say as, right, 2 plus 2, right? And then it becomes there. 2 plus 2 is 4, right? Now I can use this in the select statement, or I can use it in the where clause. So for instance, I believe we have some users here. Let's see, select star from users. And if we run that, we have no users. What? How come we don't have any users? Okay, let's see. We have no users. What's this one over here? Okay, so let's create some users. All right, so here we might declare maybe Alice Wonderland. Okay, and we might declare here Bob, Hope, and then Charlie Brown. Okay, and then Craig. Okay, and let's do apply, and inserts those 4 folks. And something went wrong. What? Executed. Username doesn't have a default value. Oh, I guess I made them required. All right, so username, I'll say Alice, and we'll say Bob, and we say Charlie, and Dan, and that's it. Let's apply. Oh, geez. values, execute, password doesn't have, I made password also some bogus passwords. Anything else? Okay, there we go. All right, so we got a couple of users. And so let's go back to where we were here. So let's now run that again. And there we go. So we got a couple of users there. Okay. Well, I can use this add in the where clause, right? So if I have the same query, I can say where, right? And say that the ID of the user is equal to add 2 and 2. Okay, so if I run that, notice that it comes back with Dan, right? Because 4 is equal to 2 plus 2, right? So I could use this function to do some, fairly sophisticated calculations, right? And then that calculation, I can then use it as part of the where clause, right? I can also have functions that can take arguments, right? So let's create another function here. And we might call this add A and B, right? That can take an integer A and an integer B, right? That then takes those values of A and B, right, and adds them together. And you can create your own variables, or you can have variables that are parameters like this, right? So if we save that and we apply, notice that it just adds what we need above and below, right, to declare this in the server. So we say apply. Now we can go back to our query, right, and perhaps use that function and say, select star from users where, right, ID is equal to add A, B, right, and we can pass 1 and 2. So it's equal to 3, right? So let's see what that comes out to be. Right, that comes out to be user number 3 is what? User number 3 is Charlie Brown. Okay. So yeah, so I can pass arguments. So I can use then that data, the parameters to run loops, to do additional queries, to views, and all sorts of things for me to be able to calculate, right, things that I can then use here in the where clause that I didn't have a function before. Now I can create functions of my own. Okay. All right. So let's see. Yeah, so I can create functions which I can parameterize, right? So this one is hard-coded 2 and 2, or I can pass in values that are parameters that can be used for some sophisticated algorithm, right? You can change the name. You can also use them in the select clause like we did earlier, and you can name the you can name the column that comes back, right? That can then be renamed so that it's easier to read and make sense alongside with other fields that you might be retrieving from tables, right? You can also have, instead of returning numbers, you can also return any other data type, varchar, date time, all sorts of other data types that, but beyond just integers and other varchars and whatnot. Okay. All right. Let's leave it here. We'll come back and talk about store procedures next week. We will be using store procedures in the upcoming assignment, and we'll be asking you to do some programming. Obviously, following the same pattern where we show you how to do something, and then we ask you to do something on your own and program using store procedures and triggers and functions and whatnot. Okay. If you could please read through this material so that when you come back on next week, we can move forward. All right. All right. Any questions?
Thank you so much.
Thank you, everyone. Have a great weekend.
Thank you. You too.
Have a nice weekend.
You too. Take
Thank
care.
you. Have a nice weekend.
Bye-bye.
Thank you.